I don't know if you know about Carnac. It's one of the most underestimated places on the planet, I think. It's not a World Heritage Site. There are loads of stones. Here are two aerial views of two parts of the Karmic Alignments. On the left, the Menek, which is the most westerly part, and then the central part called the Camarillo Alignments. In the Karnak Alignments, there are now 3,000 stones standing. But in the area, there are lots of different kinds of alignments, and it's estimated that initially there were about 70,000 standing stones in this area. Okay? So there are not only standing stones, there are lots of artificial hills, tumuluses, dolmens, over 250 dolmens, stone circles. It's an incredibly densely populated area, which is very little known, in fact. This is the Carnac alignment at equinox sunrise. Another series of alignments called the Petit Menek, which these are open all year round and go through some wooded areas. This is an overview of the Karnak alignments. On the left, then, these parts called Le Menek, east and west, and then Camarillo in the central part, and at the top here, up here, the Carnac Petit Menek. The whole thing is about 4 kilometers long. The Erdeven alignments here at the left are a bit further north, 8 kilometers north. These were much bigger alignments than Karnak alignments. There were probably 50 rows of stones here. And at the beginning of the 20th century, there was still 6,000 stones remaining in these alignments, but they've been heavily destroyed for building and stuff like that. But you've still got the east-west orientation. You can see the sunrise and sunset here at equinox. Some very big stones. This one on the left here is 6 meters 50, but the top has been cut off. So it was about 8 meters tall. So there are just thousands of these massive stones made from granite. These are the St. Barb alignments, another series of alignments. These have been incredibly destroyed, but this is what you can see remaining today. This is orientated towards the minor moonrise. This is an event I organized at Minor Moon in 2014, and over 500 people turned up to watch this moonrise along these alignments. So we're trying to keep things alive. This is another series of alignments, Saint-Pierre-Quiberon alignments on the peninsula, the Quiberon Peninsula, just nearby. And these alignments actually go into the sea. The sea has come up since then, and there are thousands of stones actually underwater going into the bay up to over 1 kilometer from the shore. Virtually nobody knows about these. I actually did a tour on these stones with people from the local county council and the tourist office, and I showed them all these stones. Nobody even knew they were there. As you can see, very big stones and very long alignments. So all this is happening in southern Brittany, in the Morbihan, it's called, the Morbihan area. All these yellow lines represent the different alignments I've been talking about. So they're all in a small area. And the ones we're going to concentrate on first are these Karnak alignments. There you go. So this is another view of the Le Menek alignments, 11 rows of stones. Start on a high point of land and then go downhill. This is the aerial photograph of these alignments. And so you can see, I'll be coming into this, there are two major directions in these alignments, and I'll go into a bit more detail about that in a second. The central part of these alignments, Camarillo, again, two central directions given by the orientation of the stones. And the southern row of the Camarillo alignments is aligned towards sunrise at summer solstice or sunset at winter solstice. So this is very specific orientations. Here they are again, these two things from aerial view. Now, what I'm going to show you now is the link between two alignments. According to the official view, none of these alignments have got any links to each other. There are no real official explanation. There's no official explanation of what this is about. But there are no links made, and everything's just treated as sort of independent. Now, here on this slide, this should allow me to click to a video. Here we go. So I'm going to show you on this video. This is done with Google Earth. And so here on the left, where the hand is on the right-hand side, that's the beginning of the Camarillo Alignments, and this is the beginning of the Lamanic Alignments. Between the two, there's about 1,400 meters, a little less than a mile. And now I'm going to draw a line from the first stone in this row at the Lamanic Alignments. You'll see this line is going to be drawn up here. And I'll draw it to the first stone here in the first row of the Camarillo Alignments. Size going from stone to another. And now the angle that comes up here is 71.57 degrees. That's the exact angle from north. This is exact to 1/100th of a degree, 71.57 degrees. And if we come back to the beginning of the leg, we see how the line, you can see how this yellow line stones. Okay, so it's quite clear that these lines are linked up. Let's look at the second line now. So I'll put a point on the second row. And then we'll go up to Camarillo. And here we have the first two stones here. And let's link up to those. So you can see how these two stones are actually aligned. And if you look at the angle again, here, I don't know if you can see it on the screen, 71.57 degrees again. Exactly the same angle to 1/100th of a degree. And if we come back to this rows of stones, you see how this line goes through the stones like this. Now, these lines go downhill and then uphill again. And so the actual view of with the change in slope and everything gives a certain sort of position. Now let's look at the third line. There are three stones at the beginning of this third line which aren't in line with the others. They're east-west. But if again I put a stone, I put the marker on the first stone of that line and then come up again to the first stone or the first two stones in the third line at Camarillo, again the angle is 71.57 degrees. Okay, so these three, the first stone in the first three rows of Lamanic to Camarillo all have the exact same angle to 1/100th of a degree. You can see how the line goes through the stones. A bit further up, you know. Here we go. If you go a bit further along the line, see how the rows are going along it. So there seems to be no doubt that these two sites, Camarillo and the Menek, are linked together. So I'll stop that video. And now let's look at what's happening as far as geometry is concerned. What is this angle of 71.57 degrees from north? If we draw the lines then, we see all these different lines join up, and you get the same width. The alignments at Lamanic are the same width as the alignments at Camarillo, and this angle corresponds exactly to the angle of a triple square. In other words, which is perfectly orientated on cardinal directions. So if you look at this rectangle you can see is 3 times longer on the east-west line than on the north-south. North-south is 1, east-west 3. And that is, if you calculate that angle geometrically, it is exactly 71.57 degrees. So this geometry is precise over a distance of 1,400 meters. It's precise to 1/100th of a degree. So I've been working on this for 30 years, and when I started, I was using maps and measuring angles and things. Only recently, using satellites and laser and stuff like that, it's now possible to get incredibly precise results. And these incredibly precise results are now showing me that the people who built these things were capable of that precision. So we're not talking about sort of amateurs, you know, these sort of first farmers who were sort of looking at the sky and vaguely positioning things. We're talking about extremely precise planning linked to exact cardinal directions, right, to 1/100th of a degree. The diagonal of a triple square, taken from the south, is 18.435, or from the north, 71.565 degrees, 71.57. Now, if we look at the other end of these alignments, I told you there were 2 angles given by these alignments. So if we look at the other end, we'll zoom in on that. This is very complicated, this part. There are lines going in all kinds of directions. It's rather difficult to sort of get a grip. But if you look at the major lines, which we can see at the top here, these are the major lines, the orientation of these blue lines. These are where most of the big stones are, and they're all lined up in the same direction. Now, if we take that angle, first of all, what we notice is that there's an alignment that links up with it along the side of the road. Can you see how the road has changed direction here? Because there's an alignment goes along there. And if we take the most northern part of this line and link it up to the beginning of the first row here, it's the same angle. So the most northern line of the east part lines up to the first stone in the most southern row of the western part. So there's some other kind of geometry going on here which is crossing over this first geometry. Makes things rather complicated, but let's have a look at what angles that gives. So here we're going to zoom in on the eastern part. You can see these rows of stones, and then goes back down to the western part where we were before. Now, there are some stones here which you can't actually see because of the bushes, but if you go back, there's a photo from Google Earth in winter where there are no leaves on the trees, so you can see a line of stones there which lead to a point. They lead to this point here. And if we go from this point here up to the first row of these alignments, now these stones here, there are some stones there which have been moved for the building and which were east-west before. But the first row of stones, you can see how these rows have exactly that angle. And that angle is 64.43 degrees. Now let's do this on the calculator. The inverse tangent of 2, 63.43 degrees. So what this means is that this angle is the angle of a 1/2 square. The inverse tangent of 2, I don't remember trigonometry, but it's 1/2 basically, and that gives you an angle. And let's get rid of this, the technical detail. So there's very precise geometry going on here, using simple numbers, 1, 2, and 3. Here you've got the measurements of it. I was very interested to discover that there was a standing stone here in the corner. And here's the angle of it, 1/2, that's the angle of the eastern part, gives you the double square. Okay? So that gives you this geometrical plan of this complex, which is a triple square for the, there you go, and if it gives you a triple square for one part and a double square for the other. And in fact, I discovered that the angle between those two, the average angle, or the angle between those two forms, is a sevenfold square. This is the geometry of it. So the alignments themselves, the major direction of the western part of the alignments follows the sides of this sevenfold square, whereas the major direction of the eastern part follows the diagonal. These lines go down this diagonal, whereas these lines go along the east-west, that go along the major axis of the western part. And this whole thing is positioned in a double square, right? It's very, very precise. It took me about 18 years to understand this. So you haven't got much time. But I spent many, many years sort of studying this, and I knew there was something to be understood here, and it was definitely eluding me. You know, I couldn't understand, and then all of a sudden, it suddenly fitted in. Now, this triple square then, as we can see, goes from the first line of one series to the next series in Camarillo here, from here to here. Now, if we add on the width of the monument, the width of the alignments, the north-south width of the alignments, and I give that a value of 1, a module of 113 meters, I discovered that the measurements involved here, are they going to turn up? Yeah. In fact, the north-south width of the alignments here is 1/4 of the total height of this triple square. So if I put this in whole numbers, I have 1 here, 4 here, and 12 here. Now 4 plus 1 is equal to 5. That's easy enough, which means that if I join the southern part of the most southern line of the western part to the most northern line of Camarillo, I get a 5, 12, 13 triangle, which is a Pythagoras triangle. And this is precise again to 1/100th of a degree. I don't have time to show you all these relationships in detail because, well, I don't have time, but it's very, very precise relationships. So this is incredible geometry showing the relationship between these shapes. But if I add another module here, now here we have a problem of landscape, because the beginning of the Camarillo lines and the beginning of the Menek lines are on high parts of land, plateaus, and then the lines go downhill. And this from here, we go downhill, and this is in a sort of ditch. It's in a low part full of water, and there are no monuments here. But if I draw a line from that spot, from this second added module, if I draw a line from there back to the beginning point here, well, it goes right down the first line of these eastern lines I showed you earlier. So instead of building this here, they've built it here. You can see how this line goes, and that creates a kind of confusion because you have lines going here and lines going here. But in fact, it's linked to the landscape because all these things are on high bits of land. So somehow they've managed to do this perfect geometry, taking into account the high plateaus of land. Okay? So all these things are on approximately the same level. So that's the double square which is added on. Now if I come back to the Camarillo alignments, I'd said they're orientated towards summer solstice sunrise. Now here you can see the lines, and they go down to a dolmen here. This is a dolmen in the corner, and this southerly line, you can see this line going down the stones here, straight to this dolmen. And that's orientated towards summer solstice sunrise. It's definitely worth coming to Brittany at summer solstice. That's why we organise an event every year, because there are so many things to see. And this is one of the big things. Of course, it's at 6 o'clock in the morning, so the days are quite long. Now, at the other end of these alignments, there's a big stone called the Manio. Here you can see it. Much bigger than all the other stones around it. And this is a kind of focal point for these alignments. You can see this yellow line, which goes along the most southerly line we saw earlier, leads straight to this standing stone. Here's the overview, okay? So the most southerly line here you have the line of alignments, and this links up here to this. This is the biggest stone in the whole of these alignments at this end here. Now, if we look at the angle of that line, we see it's 53.13 degrees. Don't know if that means anything to anybody, but that is the exact angle of a 3-4-5 triangle. So these Camarillo alignments are linked towards sunrise at summer solstice, but also have precise geometry, which means that this latitude was chosen because of its astrogeometrical properties. The people who did this came to Karnak because it was at a specific latitude which corresponded to this precise geometry, and this geometry is done by the sun itself. So this takes us into another dimension. See this right angle? Okay. And this is incredibly precise again. We're in sort of very, very precise stuff. For some reason, my 3 squares have gone off a bit. But what I later discovered, because I knew about the 3-4-5 triangle, and then I realized that there was a triple square involved in the first part of the alignments. But then what I discovered was that there's a relationship between the triple square and the 3-4-5 triangle, which is a very simple relationship, is that if I take a triple square, this one's deformed for some reason. I don't know, it was okay this morning. But if you take a triple square and you put one diagonal of that on the east-west line, the other diagonal gives you the 3-4-5 triangle and summer solstice. So a triple square inclined like that with one diagonal towards equinox, the other diagonal gives you summer solstice. Because if you double the angle of the diagonal of a triple square, which we saw was 18.435 degrees, that gives you 36.87, which is the exact angle of a 3-4-5 triangle. This is not approximate. I've rounded this off to 3 decimal places, but you can do that to 100 decimal places. It's perfectly exact. There's no approximation involved in this. It's a perfectly exact geometrical relationship. Okay? And this can only happen at the latitude of Carnac in Brittany. So this led me to discover, maybe this exists. I have talked to sort of university mathematicians about this, and they say, well, it hasn't really been formulated like this, but we knew it must have existed. Well, anyway, this is the way I formulate it. From any 2 numbers, whole numbers, different, A and B, you can get a root triangle, okay? A, B gives you a triangle, these are with an angle alpha, and this formula here gives you a Pythagoras triangle where the angle is double. So let's look at this at Karnak. B is 1, A is 3. It's the 1 to 3 relationship. And that gives me the square root of 10, on the diagonal. And that's why I call it the root triangle, because when I do the calculations, the triangle which is generated, I have 10 on the hypotenuse, and this is a 6, 8, 10, which is equivalent to 3, 4, 5. Okay? So that's the principle of the solstice relationship and equinox solstice relationships at Karnak. Here's the plan of the Camarillo alignments. with the 3, 4, 5 and the different angles. Okay, and this is the whole thing with the triple square that you see at the first part and the 3, 4, 5 triangle at Camarillo, and that gives you the geometry of the whole site. Okay, this is going very fast. Of course, all this is in the book, which is on sale, Karnak, the alignments, in the bookshop, if you need more time to study it, which I should imagine you would. Now, what I'm going to do now, I've done this all very fast because this was in my talk. I did this talk in 2011 here where I showed all this stuff already. And what I want to do now is show you how this key, all this geometry, is a key to understanding other sites all around the world. Once you've understood this, you can virtually go anywhere and come to terms with the geometry involved in placing these, in creating these megalithic sites. And they're all linked, megalithic or pyramids or ziggurats or whatever you want. They are all linked to latitude. All these sites are placed at specific latitudes linked to this specific kind of geometry. This might sound like an amazing claim, but in the next, how long have I got left? Half an hour, maybe. I'm going to try and prove it to you. So the first elements are taken from a DVD I've done called Carnac and the Pyramid Plan. Here you've got the plan of the pyramids. This is the aerial view of the pyramids. Everybody recognize this? Yeah, okay. The Great Pyramid here. And then this is the 345 pyramid, what's called the Catherine Pyramid. And what you see is that leading up to this pyramid, there's a causeway here. This is a fantastic piece of engineering, this causeway. It's called the Catherine Causeway. These images this is perfectly north-south orientated, what I'm showing you here. As you can see, the pyramids themselves are perfectly north-south orientated. But this causeway gives a specific angle. And that angle is, hang on, no, I'm not telling you the angle yet. I'm just showing you the line of the angle up the causeway. And here are some photos of this causeway. Incredible blocks. It's been made to be perfectly straight and flat on, well, flat, you know, it's sloping, but it's perfectly flat. It's not, you know, it's not going up and down. And so a lot of stone was quarried and moved and positioned to make this happen. You know, thousands of tons, it's a lot of work. And at the bottom, it slopes down and goes inside the valley temple. The angle actually continues right to the back of the valley temple. Here's a sketch of it. And this is the valley temple, and this angle goes all the way down straight and then continues in a path right to the back wall here. Now, I can't go into all the details of that this morning. I'm just going to talk about the angles because the measurements here are incredibly interesting. But I unfortunately can't go into them. So here's an aerial view. Thanks to Robert Temple for this. Here's an aerial view of this line. This is the Catherine Funeral Temple, which is at the top. It's called the Catherine Funeral Temple. That's what it's called. It's just at the base of the pyramid. Here's the pyramid. It's at the base of the pyramid. And the causeway starts at it goes into the temple a little bit here, but then the causeway starts here and goes down to the valley temple. Here it is on close-up on satellite photograph. And here's the valley temple, and you can see here how the line goes down into the valley temple and right to the end against the wall like that. There it is on aerial photograph, same thing. Now what we're going to do is look at the angle of this. The angle with respect to north is 284.04 degrees. That's the angle of this line. Now if you take the tangent of that, it's 1/4. If you do it from the east-west, it's 14.04 degrees. From the east-west line, it goes up by 14.04 degrees, which is the exact angle of 1 square by 4. Okay, so you have 4 squares. A quadruple square, there you go, 1 by 4. A quadruple square perfectly placed on cardinal directions. So here you have 1 and 4 and the square root of 17 on the diagonal. Now, if we do the same thing in Karnak, in other words, I draw an east-west line and then I slope a quadruple square with its diagonal on the east-west line, that's going to give me the same kind of situation I was showing you in Karnak. Now, let's look at the solstice angle at the Giza Plateau. This is the, what's this called? Archaeogeodesy. This is a program that gives you the exact angles, done by James Q. Jacobs and Victor Rice, gives you the exact angle at any date anywhere on the planet of the solstices and the moon. And so here you can see that at the Great Pyramid in the year 3200 BC, which is the date given by Robert Temple from his thermoluminescent test of the stones in the Great Pyramid, he got a value of 3200 BC. But if I take that as a date, I get this angle here for the solstice, 28.072, which is the exact double of the quadruple square. So we get exactly the same principle here at the Giza Plateau as at Karnak. And this can only happen at the latitude of the Giza Plateau, okay? You've got a quadruple square gives you the east-west, one diagonal gives you equinox, and the other diagonal solstice. And so if you look at that with respect to the Catherine Causeway, you see the solstice angle there. Well, that's what you get. In fact, if you stand, you get the sun setting behind the head of the Sphinx, between the two pyramids at summer solstice sunset. So what's the geometry linked to this? It's the same thing. We come back to the root triangle thing, 1 by 4. You put this into, with the root 17, you put it into the calculations, it doubles the angle, and you get a Pythagoras triangle, the 8, 15, 17. So it's the 8, 15, 17 Pythagoras triangle that actually gives you the angle of solstice at the Giza Plateau. Okay? So this is the same principle. So let's go a bit further south in Egypt. Now we're coming to Carnac in Egypt, in the south of Egypt. Same name as Carnac in Brittany, of course. This is the temple, known as the temple of, I don't know, how do you pronounce that in English? Amun-Ra in Karnak. This is the hieroglyph explaining giving the name of the place, and this actually means a place of highest esteem. I thought this was interesting because they're not talking about a temple or something, they're talking about the place itself. It's the place of highest esteem. So what's so special about the latitude of Karnak in Egypt, Karnak in southern of Egypt? Just according to Wikipedia, the main temple is laid out on an east-west axis. Let's just look at this. That is not an east-west axis, right? That's wrong, okay? The diagonal of the temple is in two parts, but if we take the diagonal here, you see there's this part and this part. If you take the diagonal of this part or this part, those diagonals are east-west. Okay, and it corresponds to the double square. All my geometry has gone off here. These should be two double squares side by side. I don't know what's happened. Something's gone wrong. But, oh yeah, that's a pity. The diagonal of this double square gives you a 3, 4, 5 triangle. Here's the angle of the diagonal of the temple. You can actually see, the geometry is wrong, but you can see the diagonal going from one corner to the other here. And that's the angle. It's our 53.13 degrees, but this is taken from north, 323.13 degrees, or 36.87 from north this way. The diagonal is the exact angle of a 3, 4, 5 triangle. Okay? And it happens to have seems to have units of measurement in meters, because we have 200 meters along that diagonal. Now, if we look at the angle, the main angle of the Karnak temple, which is what I'm doing here, if you see here, 116.56 degrees from north. So you take 90 from that, 90. So from the east-west, you take 90 from that. This is a double square again, 26.56 degrees. It's perfectly exact. So the axis of the temple of Karnak in Egypt is angled on the diagonal of a double square. Okay? And this corresponds to Solstice at that latitude in 1300 BC. You can still see this today. In 1300 BC, the sun would have been a little lower. It's come up by about its own size on the horizon. It would have been exactly just coming up on the ground along this axis in 1300 BC. So again, we have the double square, perfectly positioned on cardinal directions, whose diagonal gives the summer solstice angle at that latitude, and only at that latitude. So you can see how all these sites, Karnak, the Giza Plateau, and Karnak in Egypt, they're all built with exactly the same principle. And the latitude was chosen for that particular principle. Okay, these are the Google Earth axes. Okay, now I'm going to change in this. What I'm going to talk about now is in another DVD called How the Ancients Located Their Sacred Site. And we're going to go to Baalbek. You've probably heard of Baalbek, a place where there are incredible blocks of stones, some of them over 1,000 tons in weight. And you can see them here at the base of the temple. There's a man sitting there. You can see him here. And the size of these blocks, that goes up to here, this one. You know, we're up to about 1,000 tons, and these are the foundations of the temple. Officially, the Romans did this, but of course, nobody really believes that. You know, but that's what they say. But you know, the Romans have never been lugging about stones of this size. So this is very interesting. The Romans seem to have built on top of this platform, which is an incredible megalithic platform. Now, here you can see these pillars built on top of it. Now, what's interesting is the angle. These stones have been placed at an angle, and that angle is again exactly the angle. It's at 14.03 degrees, exactly the angle of a quadruple square, placed with its diagonal placed on the cardinal direction, on east-west, its diagonal placed on east-west. There'd be really a lot to say about this again, but I can't go into it now. But if you're interested, it's in the DVD. So again, we find the same geometry at the Giza Plateau, the quadruple square with its diagonal on the east-west line. So it's the same angle as the Catherine Causeway. So these stones at Baalbek have been orientated exactly the same angle as the Catherine Causeway on the Giza Plateau. Okay? Now I'm going to go to another spot, the Ziggurat of Earth. Have I got the time anywhere? Does anyone know what time it is? 1:45, thank you. I'm going to show a very interesting shape now called the 2x3 square. Not very complicated. It's 2 on one side and 3 on the other. It gives again a diagonal of root 17, which is the same diagonal as the quadruple square. As far as measurement's concerned, it's the same diagonal length, the square root of 17. Okay, and here I'll put the angles. These are the two angles. If you trace the diagonal of the 2x3 rectangle, you get these two angles. Okay, the larger one, 56.31, and the smaller one, 33.69. So that's the sort of introduction. Oh, yeah, and if you generate, if you use that as the root triangle, and then you generate the Pythagoras triangle, from that, according to what I showed you, this generates the 5, 12, 13 triangle. So the 2 by 3 rectangle generates the 5, 12, 13 triangle with a double angle. 33.69 doubled gives you 67.38. So that's the basic geometry of this shape here. Okay, now let's go here. This is the Ziggurat in Ur, built by Namu around 2100 BC. Ur was the biggest town on earth at that time, they reckon. About 67,000 people lived there. Well, 67,246 lived there. And we don't want to forget anybody. And this was the last thing built by the native Sumerian rulers. Okay, so that's very interesting. This is how it looked when it was found, in the 19th century, or when it was photographed in the 19th century. And it's been done, they've redone the stairs. 3 staircases of 100 steps lead up to a platform. Here's a kind of drawing of it. Very interesting, sophisticated building. And here's the north-orientated satellite image of the ziggurat. Now, if we measure the southern side of it, just the measurements, we get 38 meters. This is approximate. I'm not saying this is exactly 38 meters, but this is, the measurement that you get if you measure this side of it. And if you measure 38 meters, if you measure this side here, when I say approximate, that's exactly what you can see being measured by the yellow line. Okay, 57 meters. You get a relationship 38 to 57 meters. 38 divided by 2 equals 19. 19 times 3, 57. This is a 2 by 3 rectangle. Okay? So the ziggurat is a 2 by 3 rectangle. But it's not positioned on the cardinal directions, not like the pyramids. It's not positioned on the cardinal directions, but if we look at the angle of its southern side, we get an angle, this is from north of 236.31, which gives us 33.69 degrees, which is the angle of a 2 by 3 rectangle. So it's a 2 by 3 rectangle which has been turned according to the angle of a 2 by 3 rectangle. So what does that mean? It means that one of the diagonals is north-south, which happens to be the case. You can see it here, 180 degrees. That's the diagonal of the ziggurat, perfectly north-south. So quite clearly, this 2 by 3 geometry has been clearly, intentionally used here. Let's look at the position of the moon. Why am I looking at the moon? Because the ziggurat is dedicated to the moon. We know about this. I have writing about it. And the temple at the top was dedicated to the moon. So this is very interesting. So let's see what the moon's doing here. I can't get into the 18.6-year moon cycle in detail here, but the moon has extreme positions. I hope most of you have heard about it. The moon has extreme positions where it goes up to an angle from east-west, which is greater than the solstice angle. It goes further north at some points over an 18.6-year cycle. That's called the major moon angle. And if we look at the major moon angle at the latitude of the Ziggurat of Earth in 2100 BC, which is the date that this was built, 34.041 degrees. Now, this angle here is given as the first bit of the moon that comes up over the horizon. But I'm quite convinced that the angle that was taken was the angle of the moon sitting on the horizon, because you're not sure it's going to be a full moon. right? It might be, when the moon is at its maximum, it might be a crescent moon. There's no reason it should be a full moon. And so if you want to get an exact angle, then you can't take the top of the moon, you have to take the bottom of the moon when it's sitting on the horizon. And so if you do that at this latitude with the moon angle, you get an angle of 33.7 degrees for the moon sitting on the horizon, okay? Now, as I said, the city of Ur's patron deity was Nana, the Sumerian moon god, and the name of the city literally means the abode of Nana, which is the abode of the moon, okay? So this is a big clue. So if we look at this, we then discover then that the major northern moonrise at this latitude in 2000 BC was exactly on the slope of 2/3, which meant you would get that, okay? If you were standing on the top of the Ziggurat, then you get the staircase and the full moon coming up over the horizon, sitting on the horizon exactly on the axis, in the axis of that major staircase. That happens once every 18.6 years. So that's the geometry of the 2/3 rectangle. But what's interesting is that if you take the other diagonal gives you an angle of 292.62 degrees, or 22.62 east-west, or 63.38 from the north. It's the angle of the 5, 12, 13 triangles. So you have one of the diagonals is north-south, and the other one is exactly the angle of a 5, 12, 13 triangle, Pythagoras triangle, taken from the north, south, east, west, placed on the cardinal directions. So you can do that. Put a 5, 12, 13 triangle along the other diagonal. Now, if we look at the minor moon now, because the moon has an extreme north position, a major position, a minor position, if we look at the minor position here on this table, 112.49 degrees, we now discover that the minor moon sets at the angle of a 5, 12, 13 triangle. Okay? So when the minor moon rises, it sets, so the major moon, as we've seen, is in the major axis, and the minor moon sets along the other diagonal. Can you believe this? Just happens to be true. Okay, and this gives a relationship. I found this very interesting. This gives a relationship, because I've got a 2:3 ratio for the major moon and a 5:12 relationship for the minor moon. This gives me a relationship of distance for the major moon and the minor moon of 5:8, which are two numbers in the Fibonacci series. Okay, so that's a very interesting fact linked to this latitude. So that's a geometry you could put on the Ziggurat. But what I'm going to show you now is just absolutely unbelievable. I'd like you now to put on your seat belts. And what have I done here? Hang on a second. I hope this is going to work. Yes. Now watch what happens here. I'm going to put a point. Well, first of all, I'm going to show to you that the north-south, this is Google Earth video. Going to show to you that the north-south, as you can see, 180 degrees here. Okay. That's the north-south diagonal. 180. But now I'm going to go along the other diagonal. I'm going to put a point on that corner. And what we're going to do here, first of all, you can see it's 292, right? We're at the angle of the 5, 12, 13. But what I'm going to do is take this line, and I'm going to extend it. I'm going to extend it quite a long way. I'm going to extend it 989 kilometers, right? That's a very long way. We're going to go right across Iraq and Syria This is the beauty of Google Earth. And we're going to zoom in here near Lebanon. The place names are in French, but I'm going to zoom in here to a place called Baalbek, where we were a little earlier. So let's zoom in. Here's the town of Baalbek. There's the temple up here in the north. Here's the temple. And there's another temple here. There's an angle. Down here are the massive recumbent stones of Baalbek, and the temple's up there. And there's this temple here, which is midway between the two, and which gives an angle. Look at that angle. 292.62 degrees. It's the exact angle to 1/100th of a degree of a 5, 12, 13 triangle. So if you zoom back into, from that line, you zoom back into the Ziggurat of Earth, you see that that line goes right along that diagonal. Okay? You taking this in? Yeah, what were the ancients up to? Is that the slogan of Megalithomania? Hang on. Can I close this off? Oh dear. Hang on. Maybe I can leave that turning and come back to it this way. That's okay. So that's the resume of that. The distance happens to be exactly 32,000 arc seconds. Right. Now to finish this off, I must have about 5 minutes left, I'd like to say something about Stonehenge. So we were at Stonehenge yesterday, and what's very interesting about Stonehenge is that the latitude of Stonehenge gives an exact right angle between the summer solstice and the major moon, or the solstices and the major moon. So if you take the major solstice angle, which we saw yesterday goes to the altar stone, goes down that major axis, and you take the moon angle, the major moon angle towards the south, that creates a right angle. And that will only happen at the latitude of Stonehenge. You won't get a right angle anywhere else. Okay? Now, if you go further north or further south, you haven't got a right angle. It only happens at the latitude of Stonehenge. Now, that's a very interesting point, especially seeing as I'm very much into right angles, because I'm working with 3, 4, 5 triangles, or Pythagorean triangles, which have right angles, okay? And you use Pythagorean triangles to get right angles. That's how you do it. And if we take the station stones, so there are 2 remaining stones. The oldest stones at Stonehenge, as far as we know, are the station stones. 4 stones which were erected on the Aubrey circle. They weren't in the holes of the Aubrey circle, which are the 56 holes in a circle, which are the oldest part of Stonehenge. And there were 4 standing stones there, which seem to have been erected around 3000 BC. And those 4 standing stones are positioned in a certain way. There's been a lot of talk about this. A lot of people suggest it's a 5, 12, 13 triangle. And even Richard Atkinson conceded that it was very, very, very close. They were positioned to being very, very close to a 5, 12, 13 triangle. And here are the angles given by John North in his book on Stonehenge, all the different angles. And we can see that if you add the angles together, now, I've got something come out which shouldn't have done here. Doesn't matter, let's talk about it. If I add these 2 angles together and take them away from 90 degrees, I get the angle between these 2 station stones. So the station stones are here, 1, 2, 3, 4, and Stonehenge is in the middle. And so this diagonal between these 2 station stones from north is the diagonal of a triple square. All right, this is news, right? Nobody knows about this, okay? So that's the diagonal of a triple square. Now, if you take the other two standing stones, the other two station stones, and you take their angle, that's a double square. So here's the geometry of those station stones. There's a triple square and a double square, which create a 5, 12, 13 between them. And that 5, 12, 13, its sides give solstice and major moon. Now there's another place a bit further away called Woodhenge. I'm going to finish on this. A Woodhenge Center. These are concentric ovals, okay? They've been filled in with concrete. Maybe you know them. These are post holes in the chalk. So we've got very precise positions and measurements. And you can work out the exact center of Woodhenge. Okay, and if you take it, they're oval, so you have a long axis and a short axis, so you get the major moonrise and solstice angles in the same way here, shown by the ellipse. Now, what I'm going to do now is show you the relationship between the exact center of the Aubrey circle, so where the station stones are, these 56 holes. This is the oldest circle traced at Stonehenge. If you take the exact center and you link that to the center of Woodhenge. Is this going to come up? Hope so. Yes, here it is. So here I'm showing here the station stones, and these are the Aubrey holes. This is another station stone. So that's the Aubrey circle, and the exact center of the Aubrey circle is here. So if we put a point on that exact center, and now we head for Woodhenge, which is over 3 kilometers away. I'm talking kilometers, I live in France, you know. We go right to the center of the Woodhenge Monument here. It's to the exact center. Okay? And look at the angle. That angle is 67.38 degrees. That is the exact angle to 1/100th of a degree precision of a 5, 12, 13 triangle. The same triangle we just saw linked the Ziggurat of Earth. Look, let's get the calculator out here, just to show you. If I divide 12 divided by 5 for a 5, 12, 13, that gives me that. Take the inverse tangent, 67.38 degrees. Look at the angle on the map, 67.38 degrees. It is exact, okay? So again here, in 3000 BC, we're not talking about sort of amateurs, sort of vaguely looking at the horizon to link things up. These people the people who did this must have had incredibly precise methods to position exactly over a 3 kilometer distance the 5, 12, 13 triangle with a precision of 1/100th of a degree to cardinal directions. And that's what's interesting is then, that gives you a kind of plan for the whole of the Karnak, the whole of the Stonehenge area, because you get the grid going from Stonehenge to Woodhenge as a 5, 12, 13. And this means that from Woodhenge down the Cursus is a 2 by 18. The two station stones that give you the double square here gives you a 3 by 6 point, which comes to a spot here. So this is a suggestion of a geometrical organization of the Stonehenge area. And my time's up. So I hope you managed to follow all that. And thank you very much.